Look up at the night sky on a clear, moonless evening. Between the familiar patterns of stars, there's a faint, misty smudge, so subtle that many people mistake it for a cloud or a flaw in their vision. That soft blur is not a star. It is not a nebula within our galaxy. It is Andromeda, an entire galaxy containing trillions of stars, hanging in the darkness of space, quietly approaching us. Andromeda is the most distant object you can see with the naked eye, and yet it is also our closest large galactic neighbor. It challenges the limits of human perception, too big to comprehend, too far to imagine, and yet undeniably real. When you see it, you're not just looking across space, you're looking back in time. In this documentary, we will explore Andromeda not as a distant scientific abstraction, but as a living, evolving cosmic structure. We will compare it to our own Milky Way, stretch our minds across millions of light years, witness a future collision that will reshape the night sky, and discover why understanding Andromeda changes how we see our place in the universe. Back and index pointing right. Before we begin, take a moment to subscribe and support this channel. If you're fascinated by the true scale of space, cosmic time, and the stories written in starlight, you're in the right place. Let's begin by standing at the edge of our galaxy and looking outward. The Milky Way has always felt enormous to us. It contains hundreds of billions of stars, spans over 100,000 light years, and holds everything we have ever known. But when astronomers began measuring Andromeda with modern instruments, they realized something astonishing. Andromeda is even larger. The Andromeda Galaxy, also known as M31, stretches roughly 220,000 light-years across, more than twice the diameter of the Milky Way's visible disk. If both galaxies were placed side by side, Andromeda would extend far beyond the Milky Way's edges, its spiral arms reaching deep into intergalactic space. In terms of mass, the comparison becomes even more dramatic. Andromeda contains over 1 trillion stars, while the Milky Way holds an estimated 200 to 400 billion. Even accounting for dark matter halos surrounding both galaxies, Andromeda likely outweighs our home galaxy by a significant margin. But size alone does not tell the full story. Andromeda's stellar population is older, on average. Many of its stars formed earlier in cosmic history, meaning Andromeda began assembling itself long before the Milky Way reached its current structure. Its core is dense and crowded, glowing with the combined light of countless ancient suns. From a cosmic perspective, the Milky Way is not the main character. It is one of two giants locked in a slow gravitational dance. Astronomers say Andromeda is 2.5 million light-years away. The number is precise, but the meaning is anything but intuitive. A light-year is the distance light travels in 1 year, about 9.46 trillion kilometers. Multiply that by 2.5 million, and the resulting number becomes so large it loses all emotional impact. So let's translate it into human terms. If you could travel at the speed of the fastest spacecraft ever built, it would take tens of millions of years to reach Andromeda. If you could drive a car continuously, without stopping, it would take longer than the age of human civilization, by a factor of thousands. And yet, when you look at Andromeda in the night sky, you are seeing it as it was 2.5 million years ago, before modern humans existed, before fire was mastered, before language emerged. The light entering your eyes tonight left Andromeda when Earth was inhabited by early hominins. Andromeda is not just far away. It is a time capsule. Imagine standing on a planet orbiting a star within Andromeda. The night sky there would be overwhelming. The Andromeda Galaxy contains over 1 trillion stars, arranged into massive spiral arms that curve gracefully around a brilliant central core. These arms are dense with star-forming regions, glowing nebulae, and clusters containing millions of suns bound together by gravity. Between these stars are planets, likely billions of them. Some may host oceans, some may host life, and many may have already lived through entire histories before Earth even formed. The sheer number of stars means that even if intelligent life were extremely rare, Andromeda could still host countless civilizations, separated not just by distance, but by time itself. And all of that complexity fits inside a faint patch of light barely visible from Earth. From Earth, Andromeda looks small, just a hazy oval in the sky. But this is one of the greatest illusions in astronomy. In reality, Andromeda is larger than the full moon in angular size. Its light is simply spread out across such a vast area that it appears dim. If human eyes were more sensitive, Andromeda would dominate the night sky, stretching across multiple constellations. Long exposure photographs reveal its true form: sweeping spiral arms, glowing dust lanes, and a brilliant core surrounded by satellite galaxies. What you see with the naked eye is not Andromeda itself. It is only the brightest central region. Most of the galaxy remains invisible, hidden in darkness. This contrast between appearance and reality is a recurring theme in cosmology. The universe is not quiet or empty. It is vast beyond comprehension, and our senses only perceive a fraction of it. Andromeda is not standing still. It is moving toward us at approximately 110 kilometers per second. Gravity is pulling our two galaxies together, and nothing can stop it. In about 4 to 5 billion years, the Milky Way and Andromeda will collide. This will not be a single explosive impact, but a slow, majestic merger unfolding over billions of years. Stars will pass by one another without collision, but gravitational forces will reshape both galaxies completely. Spiral arms will stretch and distort. New waves of star formation will ignite. Entire solar systems will be flung into new orbits. Eventually, the two galaxies will merge into a single, massive elliptical galaxy, sometimes called Milkomeda by astronomers. As Andromeda approaches, the night sky of Earth, or whatever remains of it, will change dramatically. Andromeda will grow larger and brighter, eventually spanning the entire sky. Its core will shine like a second Milky Way, and its spiral arms will form glowing arcs overhead. Constellations will disappear, replaced by rivers of stars. The familiar patterns humanity once used for navigation and mythology will be erased. Future civilizations, if they exist, will look up and see a sky alive with motion, a reminder that the universe is not static, but always evolving. Understanding Andromeda forces us to confront the true scale of cosmic time. The collision will occur long after the sun has aged, after Earth may no longer be habitable. The universe operates on timescales that dwarf human history. And yet, we exist at a moment when Andromeda is visible, when its light reaches us, when we can understand what it is and what it will become. This knowledge shrinks our sense of importance, but expands our sense of connection. Andromeda reminds us that galaxies are not isolated islands. They are part of families, groups, and vast cosmic structures bound together by gravity. Our galaxy is not alone. The same forces shaping Andromeda shape the Milky Way. The same cosmic story is unfolding everywhere, written in starlight and time. And when you look up and see that faint blur in the sky, remember, you are witnessing another galaxy, another future, another chapter of the universe, already on its way toward us. If this journey through Andromeda expanded your sense of space and time, subscribe to the channel and join us for more deep explorations of the universe. Leave a comment with the question that fascinates you most about galaxies, cosmic collisions, or the future of the universe. Because the universe is vast, but understanding it brings us closer together.